Okay, now we talked about the probability experiment. You can use your data to do something, but sometimes you're not going to do it. You're just going to theorize what happens. In that case, the probability of an event occurring is the number of ways it can occur divided by the number of possible outcomes. People usually call it the number of outcomes that contain the event, and divided by the number of outcomes in the sample space. You can think of it in whatever way you want. Suppose the fun-sized bag of M&Ms contains 9 brown candies, 6 yellow candies, 7 red, 4 orange, 2 blue, and 2 green. Suppose a candy is randomly selected. What is the probability that it's yellow? So I need to take the number of yellows divided by the total. In order to do that, though, I need to find the total. 9 plus 6 plus 7 plus 4 plus 2 plus 2 is 30. So the number of yellows is 6. 6 divided by 30, which is 0.2 or 1/5 if you leave it as a fraction. I don't remember if your homework asks you for decimal or fraction. What is the probability it's blue? There's 2 out of 30 here. So blue divided by total should be 0.067 or 1/15. Comment on the likelihood of the candy being yellow versus blue. It's more likely to be yellow than blue because there are more of them. Which I don't think you guys would have had a hard time figuring out there, since there's more yellows than blues. Okay, a dice question. These are all the 36 rolls you can get when you roll 2 dice. So suppose 2 fair 6-sided dice are rolled. What is the probability of rolling doubles, which is 2 of the same thing? So we've got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. That's 6 of them out of the 36 rolls, or 1/6, which is 0.167 rounded to 3 decimal places. Is it rolling an unusual? A 1 in 6 chance isn't that unusual. Well, it's not likely. I wouldn't say it's unusual. Usually we say unusual is something that has a less than 5% chance of occurring. This is not one of those. Cards. I'm going to go on my soapbox for just a second. The thing that shocks me the most about teaching young college students is that none of them know what is in a 52 card deck of cards. They don't know how many of a suit there are. They don't know how many of a card there are. And it reminds me that none of you have to entertain yourselves with cards anymore. You have phones for that. The internet was around before you were born. It's a weird world. Okay, so here are your 52 cards drawn out for you. Suppose a card is drawn from a standard 52 card deck. What's the probability of getting a heart? There are 13 hearts out of the 52. Just 1/4 or 0.25. Probability of getting an ace. There are 4 aces out of 52. Just 1/13. This is something like 0.07. 0.074. Something like 0.077. What's the probability of getting an ace of hearts? Now, of the aces, only one of them is the ace of hearts. So it's 1 out of 52. Can't reduce. It's a small number. 0.019. Subjective probability, we don't tend to use, I discourage you from using it, is a probability obtained on the basis of personal judgment. An economist predicting there is a 20% chance of recession next year would be a subjective probability. What's another example of a subjective probability that's appropriate in today's world? There's about a 90% chance someone who makes a racist comment will then turn around and apologize for it the next day, and people probably won't believe them. But anything that is just a random judgment, with those statistics that are made up. I could say something. I believe there's only about a 30% chance we'll be full-time back at school in person in the fall. So that's what subjective probability is. It's just you taking a number and making a judgment. I mean, it doesn't have to be completely random. It's kind of an educated guess, but either way, it's subjective probability. And that's all for 5.1.